Okay, we're on page 20 of your packet, and we're just going to go over 4 little examples of factoring. You have seen factoring before, probably. Can you raise your hand if you have seen factor, if you've heard of the word factoring? Not, I know how to do it, but I've heard of it at some point. Okay, so the majority of you have heard of it. Hopefully, those of you who think you haven't, it'll kind of jog your memory as we do this. But can you guys tell me, so if you look at this one right here, this one may look different than normal factoring that you've seen before, but what do these two have in common? These two numbers right here. What do they both have? They both have an X in it, right? Okay, so if they both have an X in it, you can pull that X out, and then you'll pretty much be done. So if we want to divide both of these by X, it's kind of like the opposite of distributing. We're pulling that X out, so we have X squared, that just becomes X, and then minus 5, and that's going to equal 0. So since they both have X, and we don't have an extra random number over here like we do on number 2, we can pull X out. And then it says to solve each equation by factoring, so we need to go ahead and figure out what does X equal. And there are going to be 2 answers for this on all of them. X is going to equal 0 for the first one, because you're going to set each of these equal to 0. And then X minus 5 is also equal to 0, but we need to solve this one. So we're going to add X on both sides. X equals 5. Okay, I'm going to show you 2 different ways to factor. I prefer to use way number 2, and this is when the coefficient is 1. All right, notice this one over here, the coefficient is greater than 1, meaning the number before X squared is greater than 1. This one is just 1. So I think this is the easiest way to do it. I'll show you a different way to do it on number 3. You are going to take this number, your C coefficient, because it's A, B, and C, and you are going to find 2 numbers that multiply to equal negative 12 and add to equal positive 4. Alright, so I'll write that over here. So it's kind of jog your memory. Multiply to equal negative 12. Adds to equal a positive 4, or your B coefficient. Positive 4. Okay, negative 12 times 1. Or just 12 times 1, the negative can be on the 1 or the 12. But you can't find a way to add those to equal positive 4. Alright, so next we've got 6 and 2. Ooh, yes, because one of these has to be negative, right? And then one of them has to be positive. So we can make, which one of these will we make negative to add them to equal 4? Yes, you know. So if we make the, what do we think? The 6 or the 2? So if we make the 2 negative, it would equal a positive 4, right? Okay, so what I'm going to do is I'm going to take these 2 numbers, these 2, this is how we found them. We multiplied to equal 12, and they add to equal 4. Those are our 2 numbers. We're going to take X plus 6 because this is a positive 6 here, X minus 2 because it's a negative 2. Set the whole thing equal to 0 because this one is equal to 0. And then we've got this, and so if your question just said, hey, factor, then we'd be done, but it says to solve. So we want to do X plus 6 equals 0, X minus 2 equals 0, so X equals negative 6, X equals 2. Okay, I did that very quickly, but I just subtracted 6 on both sides and got negative 6, and I added 2 on both sides and got a positive 2. Alrighty. That is factoring in a nutshell with a coefficient of 1. Alright, I will also show you the box method with this way. You have maybe seen it before. Some of you maybe are like, I prefer to use X method or something else. Go for it. That's fine with me. I'm just showing you a different way that may be helpful. Okay, we want 0 on the right-hand side, just like questions 1 and 2 had. So I'm going to move this in over here by adding in on both sides. N squared plus n minus 20 equals 0. I'm going to do the same thing as I did before, where I take my negative 20, and I want two numbers that multiply to equal negative 20, add to equal a positive 1. So I know I'm showing you a different way, but all of these steps are the same. So negative 20, or really just 20 times 1 equals, oh no, we can't make that equal 1. 2 and 10, one of them has to be negative, but we still can't combine them to equal a positive 1. Ooh, but then we've got 4 and 5. So one of these has to be negative, which is perfect, because then if one of them is negative, then they can add to equal a positive 1. So we want the 4 to be negative, because 5 plus a negative 4, which is what we talked about last time, combining those integers in our head, is going to equal positive 1. So x plus 5, x minus 4, oh, it should be n's. I'll change it to n's. I should have just changed it at the beginning because I always write x's. N plus 5, n minus 4 equals 0. But what if you want to use box method? You're going to get to this same spot, but if you'd like to use box method, let me just jog your memory. Make sure there's room up top to right. I didn't leave a ton of room. Let me show you how to do it again. Your a coefficient, n squared, is going to go here. Your c coefficient, negative 20, is going to go here. And these two boxes are where your 5 and negative 4 go. And they need to have n's next to them. Because if you combine these, if you add them together, they're going to equal that b coefficient, which has an n next to it. And then if you guys remember these words, greatest common factor, that is what we're trying to find in the columns and the rows. So we want the greatest common factor between n squared and 5n. So what do those have in common? What's the greatest common factor between those two? Just the letter n, right? Love it. That one can be tricky sometimes because you're like, oh, I want to think of a number. No, it's just n. They both have an n. Well, this one, they don't both have an n. But what is the largest number that will multiply into both the negative 4 and negative 20? Okay, I'm glad you guys said negative 5, because that's what people automatically think. Oh, negative 4 times negative 5 is 20, so that's our answer. But we're looking at for numbers that go into negative 4, so you can't multiply negative 5 times something to get negative 4. Okay? We are looking for factors. So negative 4 times 1 will equal negative 4. Negative 4 times 5 will equal negative 20. So that means that negative 4 is a factor of both 4 and 20. So that's what you're looking at. A number that goes into both, can multiply into both of these. And another thing I want to point out, the reason it's negative is because this 4 is negative. If that 20 was positive, it doesn't matter. The 4 is still going to be negative. So it's whatever the closest number is to it. That's the easiest way to think about it, I think. Okay, we're going to go sideways. We've got n again. That's the largest number. Okay, what's the largest number that multiplies into both of these? 5. Okay, so now we're getting that idea. Good. It's not 4, because I get it. 5 times 4 is 20, but 4 can't go into 5. But 5 can go into 5. And this 5 is a positive, so that means this 5 is going to be a positive. Okay? So I know that took longer. You'll need to use it for, if you want to use this, for these types of problems with the coefficient of 1, go for it. You don't necessarily have to, because we did all that work and then we got the same thing as what we did here. But that is a, something that you can use. All right, we're going to now solve n plus 5 equals 0 and n minus 4 equals 0. We're going to subtract 5 on both sides. We're going to add 4 on both sides. And voila! We have n equals negative 5 and n equals 4. Cool. For number 4, this last one. Now it gets kind of different. It becomes more difficult. I'm going to use box method for this because I think it really helps you to see it better. And it's kind of actually necessary for this. But if you have another way that you prefer to do it, go for it. So I'm going to write the steps down. This first step, we've got an A coefficient, a B coefficient, and a C coefficient. So we've got 3, negative 25, and positive 28. And it's important that you know what A, B, and C are because I'm going to refer to them as A, B, and C. You want to multiply A and C. I guess I can write A and C. That's an and symbol. That just makes everything confusing. Multiply A and C. Write it however you'd like. So we get 28 times 3, and that's going to be 84. And that's what we put in our little T-chart that we've been making. And then, so then we want to find two numbers that multiply. There's my alarm to take attendance. Multiply to equal 84. And I will move my hand in just a second so you guys can see it, but I'm left-handed. And add to equal negative 25. I think that's to tell us to take attendance. I don't know what that was. That was weird. But I just wrote the steps down, and that way when you look back, you kind of remember, like, what the heck am I doing? I remember now. Yeah. So we've got 84, because that's A times C. And then we want to multiply, have them multiply, two numbers to multiply to equal 84, add to equal negative 25. Yes, there we go. I finally listed it out. All right, 84 times 1. That doesn't work. 42 times 2. No, we can't add those together to equal a negative 25. And if you think about it, really we need both of these numbers to be negative because we need this to equal a negative 25. Well, I guess that's not necessarily the case. Yes, it is. Because to equal a negative, it has to multiply to equal the positive. Okay, I was right. 3 times... Is 3 times 28? Is that what it is? Okay. This is where it gets confusing. Because you look at it and you're like, oh shoot, I can have negative 28 and a positive 3, and that would equal negative 25, right? That's what you think when you look at it. But does negative 28 times negative 3 equal a positive 84? No, it doesn't. So that's what kind of makes it a little bit confusing. If this was a negative 84, then sure, that would work. It's not. So you got to keep going. So this one's a tough one. All right, the next one is 21 and 4. So 4 times 21 equals 84. And if both of them are negative, they can add to 25, right? Okay. Some of you guys were like, yeah, I could do that in my head like a lot faster. But this T-chart is a way to figure out those factors. And, you know, if you're having a hard time thinking about it. Okay. So now I'm going to make my box, my a coefficient is going to go here, 3x squared. This is where a lot of people mess up. They want to put 84 here. Don't. You're going to get it wrong. You want to put your c coefficient here. And then last thing, we want to put these two numbers. So you can put 4 or 21 in this box. And you can put 4 or 21 in this box. You just got to pick one. It doesn't matter which one. Alright, greatest common factors here. This first column is just x. Because no number greater than 1 goes into either one of those. Okay, can anyone help me with the greatest common factor here? It's going to be negative, because 21 is negative. Yeah, no, that's good. Negative 7, right? Okay. 7 is the greatest common factor between those. Alright. Somebody else, can you think of a greatest common factor, Simon? For this row right here. 3x. Perfect. I'm glad that you said x. A lot of times people just say 3. But they both have x in it. Okay, and then somebody else, you think the largest number that multiplies into both of these numbers. It's going to be negative. Yes. Negative 4. Great. Because 4 times 7 is 28. Okay, we've gone through all of our steps. X minus 7. We're going to pull this down here. 3x minus 4. We're going to pull this down here, and it's going to equal 0. And then our very last step is just to set each of these things in parentheses equal to 0. Hello.
I forgot to give you enough tin sticks for the balance thing.
Okay. We're not using them in advance, but
oh, that's right.
Yeah, so. Because we're doing a factoring station, which is so fun for them.
For some reason I had it in my head you needed 1 tin stick, but you need like a couple.
Okay. So x equals 7. And then 3x minus 4 equals 0. We're going to add 4 on both sides. And then you've got this. Oh, gross. 3x equals 4. You're going to end up with a fraction, and it's okay. Don't freak out about fractions. You get 4/3, and you are done. A lot of times these are going to end up with fractions, but it's all good.